All right, Andrew, we're going to do a short lesson on surface area and volume. Surface area is like what you've done in the past, calculating the areas of two-dimensional objects. So you're probably well practiced in that, the geometry and stuff like that. We've got, from your perspective, two-dimensional objects like a rectangle or a circle. They look flat because they are flat from your perspective. They have two dimensions, just going across like this. Length, width, dimension 1, dimension 2. What we do with a three-dimensional object to calculate the surface area is we sum together all of the areas of each and every surface. So, start off with a flat object like this. We know what the area is. It's got a diameter across all the way and a radius from one edge right into the center. Those are the key dimensions for a circle. For your rectangle, you've got your width or length, however you want to label them. Basically, your two dimensions. The area of these two shapes can be calculated pretty simply. Length times width, or in the case of your circle, you've got your pi or 3.14 times your radius again. So in other words, pi times radius squared. So you know how to calculate the area of very simple surfaces: squares, rectangles. You can calculate the area of triangles, circles, all of these shapes. And these are going to come in handy for surface area because essentially what you're doing is you're dividing a three-dimensional object, because we see this, and now we consider the fact that it goes all the way around. It is three-dimensional. So it has a surface area here, just like a rectangle, and then it's also got other surfaces all the way around, and they're all rectangles. So a shape like a rectangular prism is composed of 6 different rectangles. So count them up. 1 on the side, 2, 3 on the top, 4 on the bottom, 5 on the front, 6 on the back. Same goes for a cube, because all that's different in the case of the cube is all of the lengths and widths and even the depth are the exact same. So you've got 6 rectangles or squares in the case of cubes, which actually compose the entire surface area of a rectangular prism. So you calculate what the area of each individual surface is and add them together. Each surface has a unit of a meter or a centimeter, whatever, squared, since you're multiplying meters by meters, length times width, together to get that area. And then when you add together all of your surfaces, each one combines together to inevitably make a total surface area, which has units of meters squared or centimeters squared or inches squared, whatever you seem fit to deal with. A circle, in this case, when we add an area to it or a depth, we get a cylinder. So we have our surface area, the area of a circle. We have an identical surface at the back, and then we've got the edge around it. Now this edge around it, we don't know of any real shapes that are very similar to this, but if you can imagine, and this is all it is wrapping a piece of paper all the way around it and then unrolling it, we know that we can get a flat two-dimensional object out of it. So in the end, the area that's covered around the edge can be related to a rectangle. So that inevitably ends up being just a calculation of the length around it, since that's the length that the paper has to go around it, times by the height, since that's going to be the other key dimension. So the depth going from there to there. You multiply the perimeter around, which is pi 3.14 times diameter, and then multiply that by the height or the depth, and that's the area of that rectangle. You add that together with the other two surface areas, the areas of the circles, and that is the total surface area of a cylinder. Surface area can also be applied into that broken down shapes method for square-based pyramids, for cubes, as like I alluded to beforehand. For more complex shapes like cones, the surface area. So if you can imagine a cone, it starts out as a wide circle on the bottom and then comes to a point. That surface area, or the area in that case, when you look at it from the bottom end, or from the bottom end where it's a circle, it looks like it's a circle. But the area changes as you increase along its height. So you can't use the same analogy, but in cases like this, you use the formula. The surface area of a sphere is similar to that. So use those formulas when it comes to those shapes. But try and always remember that the logic or the mentality of calculating the area of each of the surfaces of an object, that holds true no matter what you're doing. That's if you ever find yourself in a situation where you don't know what the equation is or you forget what the equation is, try and break this shape down into simple surfaces and add together each one of those simple surfaces areas, and that'll give you the right answer, or at least close enough to it that you'll get a lot of the part marks, and probably encouragement from your teacher considering you came at it through a different approach. Volume also works with three-dimensional objects. So in this case, we've got a 3D object. We've got the length and width, dimension 1 and 2, and then the third dimension, the depth. Now, the volume is the space occupied by a three-dimensional object. So it's the area times by the third dimension. The area, like you see here, multiplied by this depth. That will result in the volume that you've got, the volume of this rectangular prism. Similarly, you've got your flat 2D object, multiply it by the depth, and that is the volume of this object. Surface area is measured in units of meters cubed, centimeters cubed, whatever the unit is, cubed, because it's a unit times a unit times a unit to make the cube. Now, when you're dealing with volume of more complex shapes like spheres or pyramids, again, go back to those formulas. But in the end, it's because you don't have those constant areas all the way along the third dimension. But in the end, the volume is the space occupied by an object. And that's the key point you have to always fall back on. If you have any other questions about these things, feel free to send me an email and I'll be able to help you out. Okay?